Lately, there's been a lot of buzz around Model Context Protocol, or MCP. If you're wondering what it is and how it works, you're in the right place. Today, I'll show you how MCP works, why it's a game changer, and how to add an MCP server to Cursor AI to fetch real-time weather data. Stick around till the end. So, how does Model Context Protocol, MCP, actually work? Let's break it down step by step. Think of MCP like a USB-C port for AI applications. Just like USB-C standardizes how we connect devices, MCP standardizes how AI apps communicate with different tools, databases, and services. At its core, MCP follows a client-server model. An AI-powered host application connects to multiple MCP servers to access various tools, resources, and prompts. MCP has three key components. The host is any AI-powered application, like Cursor AI or Claude Desktop, which provides an environment for AI interactions. It runs an MCP client to communicate with external servers. The MCP client is the middle layer inside the host that connects to MCP servers. It acts as a bridge between the AI application and external tools, handling all data exchanges. The MCP server is where the magic happens. It's responsible for expanding the AI's capabilities by giving it access to different functionalities. The server provides three essential things: tools, resources, and prompts. The tools let AI take action, not just generate text. Example, a weather API that fetches live weather data. The resources give AI access to real-time data from external sources. Example, a financial AI retrieving stock market updates, and the prompt's predefined templates for structured AI responses. Example, a customer support AI using standardized greeting messages. With MCP servers, AI becomes more dynamic, interactive, and powerful. Now that we understand the MCP server, let's see how the client and server actually communicate. The MCP client sends a request asking the server what it can do. The MCP server replies with details about its available tools, resources, and prompts. In a standard API setup, developers must hard-code parameters. For example, a weather API may initially require location and date. But what if you later introduce a unit parameter, Celsius or Fahrenheit? Every user must update their code, or their requests might break. MCP offers a dynamic, flexible approach. When an AI app like Claude Desktop connects to an MCP server like a weather service, it first queries the server's capabilities. The server responds with its available tools, resources, and prompts. If you later add a new parameter, the client automatically adapts without rewriting or redeploying code. With MCP, AI apps evolve in real time, making integrations smarter and more efficient. The first question is, where do you actually find MCP servers? So there's a couple of different resources that I'm going to share in this video so that you can easily go and have a look at lots of different types of directories. So have a look in this video, and I'll attach a load of links that you can use to find different types of MCP servers. The first up is there's a GitHub repository called Awesome MCP Servers. And this has a bunch of different MCP servers that are bundled by things like developer tools, file systems, marketing, monitoring, search, etc. There's also lots of different types of directories, such as MCP, dot, and they have featured MCP servers. And once you go and have a look at these, they have different types of ways of installing these, and show you exactly how to do that. So have a look at that. Also, another directory that's quite interesting is Smithery. So, for example, if we're looking at Brave Search, it will also show you in Smithery exactly how to install that, whether you're using Claude Desktop, or Windsurf, or Cursor, or Client. So have a look at that one if you want more detailed instructions about how to install that specifically with npm or scoop, or if you're using Cursor, then you just put in your API key and it will generate you the documentation for that and the installation commands. There's also Glamour AI, which is another open source MCP server directory. So have a look around. There's probably an MCP server that already exists that you can use to specifically accomplish a task and add additional functionality to your Cursor IDE. All right, now let's see this in action by adding a real MCP server to Cursor AI. Open smithery.ai in your browser. Search for weather in the marketplace. Select a server that provides real-time weather data. Click at Cursor, select JSON, and then choose Windows or Mac. Copy the JSON. Now that we have our MCP server, let's connect it to Cursor AI. Once you have an MCP server, adding it to Cursor AI is super simple. Here's how to do it. Open Cursor AI. Go to Settings greater than MCP servers. Click Add New Server and paste the JSON from smithery.ai. Click Save and Connect. Now Cursor AI is officially connected to the Weather API MCP server. But let's put it to the test. To see if our MCP server is working, let's send it a request using latitude and longitude to get real-time weather data. Now, inside Cursor AI's chat, I'll type this prompt. Get the current temperature and conditions for latitude 40.7128 and longitude -74.0060. Since these coordinates belong to New York City, Cursor AI should query the MCP server and return real-time weather data. Boom! We just pulled live weather data into Cursor AI in real time, without writing a single API call. And that's how MCP supercharges AI applications. If you found this useful, hit like and subscribe for more AI and coding deep dives. And tell me in the comments, what other MCP servers should I test next? See you in the next one.